Hi guys, this is Dr. Edwards again. Let me talk to you a little bit about complex numbers and complex functions. So, it turns out that we know very well the real number system, but it turns out that the real numbers are also complex numbers. And so, complex numbers becomes an extension of real numbers. So, every complex number has a set of two. It has what we're going to call the real part and the imaginary part. And so that becomes an extension to what you've already been thinking about. So here's the best way to think about it. A complex number, the author says, is no more than an ordered pair of two real numbers. That ordered pair is important. Parenthesis A comma B. And generally B comma A is not the same as A comma B. A has its own real property numbers, and B has its own real property numbers, although the B's are called imaginary numbers. So Z then is equal to some variable. X is a variable here, and Y is a variable. They are independent of each other. Y, when you see this kind of description, Y does not depend on X. It's totally independent. This is not the typical Cartesian coordinate system. Okay, so you can go on. Then you can talk about adding two complex numbers. So some complex number 1 plus complex number 2. Then you add the real part of 1 to 2, comma, the real part of 1, the imaginary part of 1 to 2. You can also multiply. Multiplying using the for rule, as you will see, has this interesting negative sign in the sum products of the real parts. It's a plus sign in the sum products in the imaginary part. So this I then has this interesting property I, as it's called, is the square root of -1, or I squared is equal to -1. I, is the square root of -1. Convince yourself that Z can be written in this manner or in that manner. Equivalently, it is the set of x comma y or x plus I times y. This is often the way you see it in an elementary setting for the complex number Z. Okay, let me go on. A whole set of properties that complex numbers have. So it's like a new space, if you will, similar to the Euclidean space or the Cartesian space, but now you have this one, the vertical column is what we call the imaginary set of numbers, and the horizontal is the real set of numbers. These properties are there. So the space of complex numbers is closed under addition and multiplication. What that means? Meaning that if two complex numbers are added or multiplied, the result is also a complex number. It's not like that if you multiply two complex numbers, you get something weird that doesn't exist. No, you get another complex number. If you add two complex numbers, you get a complex number, etc., etc., on and on. The complex conjugate now needs to be talked about, and that is what we call negative I. So I was going to appear over and over in various expressions. So if you have Z equals to X plus I times Y, then the complex conjugate is often written Z star. It's X minus I times Y. So Z times Z star is always then a real number, has no imaginary part. It is X squared plus Y squared in this description. Okay, so consider this information here as well. You can talk about functions of complex variables, and we'll have some of that description. So you can represent it, as I said, as in the XY XY coordinate system, or you can represent it by polar coordinates, r and theta, or x and y. If you know one set x and y, then you can find r and theta. Notice that if I give you x and y, I can find r, and if I give you x and y, I can find theta, and vice versa. So if one set exists, the other set exists also. And this is the origin diagram. The real part of the complex number is always plotted along the x-axis, and the imaginary part is plotted along the y. So then the complex number is some point in this complex plane. Okay, on and on and on here. Talk about the complex numbers now relative to this unit circle. So r is equal to 1. So every point is a point on this unit circle when r equal to 1. As theta change, you get different points along this along the actual circle. And these are good identities for you to know, these special values. E to the I power 2 is equal to I. E to the I pi is negative 1, on and on. E to the 3 power 2 is negative I. And e to the 2 I pi is the same as e to the 4 I pi, e to the 6 I pi, etc. And they all are equal to 1, and similar kind of expressions there. Okay. I want you also to know that you can find roots and powers. So this information that I'm verbally describing here now is on Blackboard on the concept, so you can go there and read through this many times, as well as listening to my video presentation and get a real good understanding. So now you can describe, so you can find powers and roots, like you can find the square root of 10. You can also now find the square root of a complex number, or the cube root, or the fifth root, or even the nth root. You can find the nth root of a complex number. And most generally, the nth root of a complex number z, written in the polar form, is r to the 1 over n, e to the I, the quantity 5 plus 2 m pi over n. And you read through here and it'll tell you what each of those m must be an integer. Also n is an integer as well in most cases. He illustrates here that if you want to find the cube root of 1, well, the cube root of 1 has one real result, but it has also these two complex numbers for the cube root of 1. If you multiply this number by itself 3 times, you will get 1. If you multiply this number 3 times by itself, you will get 1. Similarly, the 1/3 root of I is these 3 numbers here. And they've been found with this general formula, as I say. Let me go back to the formula. This is the most important formula that I've given right there. You can find all the roots that way. Even the problem that I've given you for homework, the roots can be found right there. Okay, so I've given you homework problems then 1.186, that is given here. And I let me see. That ought to be able to get a little wider, seem like. Okay, I'll leave it alone. And then 1.8.10 and 1.8.11, these are problems I've given you for homework. In my next presentation to you, I'm going to give 1 or 2 solutions to parts of 1.110 and 1.811, okay? All right, and that's what I wanted to get this out to you. So I'm going to be doing lots of these different kinds of videos, and that will help you out with information in this subject. Have a good day.